Imagine standing in a vast grassland 30 million years ago, watching the horizon shimmer in the heat. Suddenly, something moves in the distance. At first, you think it might be a tree swaying in the wind, but then you realize something incredible. That's not a tree at all. It's an animal so impossibly tall that its head towers above everything else in sight, reaching heights that seem to defy the very laws of nature itself. This colossal creature was Paraceratherium, and it holds a record that has never been broken, and likely never will be. It was the tallest land mammal that ever lived on our planet. Now, you might be thinking, this was some kind of ancient elephant, or maybe an early giraffe. But here's where things get really wild. Paraceratherium was actually a rhinoceros. Yeah, you heard that right. A rhino that stood as tall as a 2-story building, with a neck longer than most cars and legs that could stride across landscapes like they were stepping stones. But how does a rhino become a giant? And more importantly, what happened to these magnificent beasts? Why aren't they still roaming our world today, making elephants look like house pets? The answers to these questions take us on a journey through time, evolution, and the delicate balance that determines which species thrive and which disappear forever. Because Paraceratherium didn't just grow big by accident. Every inch of its incredible height was shaped by millions of years of evolutionary pressure, environmental changes, and a world that was completely different from anything we know today. When the first fossil fragments of this beast were discovered in the scorching deserts of Pakistan back in 1846, scientists had no idea what they were looking at. More pieces started turning up across Asia, but it wasn't until 1922, when researchers found better remains in Mongolia, that the picture began to come together. And what a picture it was. From studying the bones, scientists could tell this animal belonged to a group called Perissodactyls. These are odd-toed ungulates, creatures that walk on an odd number of toes. Today, this group includes horses, tapirs, and, yes, rhinoceros. But determining that this massive creature was actually a rhino, that took some serious detective work. You see, it's not the horn that makes a rhino a rhino. It's actually the teeth. Rhinoceros have very distinctive molars with specific patterns that are like fingerprints for the species. The upper molars have a chewing surface shaped like the Greek letter pi, while the lower molars show more of an L-shaped pattern. And sure enough, Paraceratherium had exactly these telltale dental signatures. Early reconstructions tried to make this animal look like a typical rhino, giving it short, stocky legs and a neck that stuck out parallel to the ground. But as more fossils were uncovered, a completely different picture emerged. This wasn't your typical rhino at all. Instead, it looked like nature had taken a rhino, a giraffe, and an elephant, and somehow combined them into something entirely new. The neck alone was extraordinary, stretching between 2 and 2.5 meters long and held at an angle like a giraffe's. But unlike a giraffe, this creature had thick, column-like legs that had to support an absolutely massive body. The proportions were unlike anything we see in modern animals, creating a silhouette that would have been both graceful and imposing against the ancient skyline. This was an animal that could reach the highest branches that no other creature could access, browsing at heights that gave it an exclusive dining experience. But size comes with costs, and Paraceratherium was about to discover just how expensive it could be to be the biggest mammal on land. But before we dive into what ultimately brought down these giants, we need to understand how they got so impossibly large in the first place. Because Paraceratherium didn't start out as a towering colossus. Its story begins much smaller, much faster, and in a world that was rapidly changing around it. The evolutionary journey that led to Paraceratherium started with creatures that looked nothing like the giants they would become. Picture Hyraceus, a lightly built herbivore from the Eocene epoch that resembled something closer to a modern tapir. This little ancestor had the same distinctive tooth patterns we talked about, but it was built for speed, not size. It needed those quick reflexes and nimble legs to escape predators in a world full of dangerous carnivores. From Hyraceus came 3 different families of rhinos, each taking their own evolutionary path. One group would eventually lead to our modern horned rhinoceros. Another became an extinct family of hippo-like amphibious rhinos. And the third? Well, that's where our story gets interesting. This third group kept those long legs from their ancestors, but they started doing something different. They started getting bigger. Take Paraceratherium, for example, living about 50 million years ago in China. It was roughly the size of a collie dog and used those inherited long legs to outrun predators across the landscape. But already, you could see the seeds of change. Fast forward to Juxia from the late Eocene epoch, and now we're talking about an animal the size of a horse. It had developed a longer neck too, probably to help it browse in places other mammals couldn't reach. This was the beginning of a strategy that would define the entire lineage. Go where others can't go. Eat what others can't eat. By the time the Oligocene epoch rolled around 35 million years ago, this evolutionary experiment had produced something truly spectacular. Paraceratherium measured a staggering 4 to 6 meters tall at the shoulder and stretched about 7.5 meters long. With that extended neck, its head could reach heights of 6 to 9 meters off the ground. To put that in perspective, it could have looked into second-story windows without stretching. But here's where things get really mind-blowing. Scientists think Paraceratherium was probably pushing the absolute upper limit of what's physically possible for a land mammal. We're talking about animals that weighed between 10 and 15 metric tons, with the largest individuals possibly reaching 20 tons. That's roughly the weight of 4 modern elephants combined, all balanced on 4 legs. Now, you might think this size limit exists because of biomechanics, like the bones simply couldn't support any more weight. But the reality is far more interesting and has everything to do with something much more fundamental: making babies. You see, there's a cruel mathematical relationship in the mammal world. The bigger you are, the longer your pregnancies become. African elephants, currently the largest land mammals, carry their young for up to 2 years. Imagine being a female Paraceratherium, potentially twice as heavy as an elephant. The energy and nutrients required to grow a baby that large, and then to nurse it afterward, would be absolutely astronomical. And that baby couldn't afford to stay small for long? In a world full of predators, growing quickly wasn't just an advantage, it was survival. This created an incredible biological bottleneck that may have ultimately determined just how big land mammals could ever get. So, what ultimately brought down these magnificent giants? It wasn't a single catastrophic event, but rather a perfect storm of challenges that even their incredible adaptations couldn't overcome. As Earth began cooling around 33 million years ago, the lush forests that Paraceratherium depended on started disappearing, replaced by shrublands and savannas. But these climate changes alone weren't enough to doom them. These were tough animals, already adapted to harsh environments. The real game changer came from an unexpected source: the arrival of Gomphotheres, ancient elephant relatives migrating from Africa. These newcomers didn't directly compete with Paraceratherium for food, but they did something far more devastating. Just like modern elephants, they pushed down trees and transformed woodlands into grasslands, accelerating the destruction of the very habitat Paraceratherium needed to survive. With less food available and increased stress from habitat loss, these giants became more vulnerable to disease and drought. Their massive size, once their greatest advantage, now became their greatest liability. The energy demands that had pushed them to the theoretical limits of mammalian biology finally caught up with them. By the start of the Miocene epoch, the age of the giant rhinos was over. In their place, those elephant relatives diversified and claimed the crown as the largest land mammals, some eventually growing even heavier than Paraceratherium itself. But Paraceratherium still holds one record that may never be broken. It remains the tallest mammal that ever walked our planet. Its story reminds us that evolution is a constant balancing act between advantage and cost, between adaptation and limitation. In a world where bigger often means better, Paraceratherium discovered that sometimes being the biggest of all can be the very thing that brings you down. The next time you see a modern rhino or elephant, remember their towering ancestor that once ruled the ancient world from heights we can barely imagine.